Coming. I know it's late, and I'm kind of glad at least there's more than two people, because everybody else might be already gone. So yeah, I'm Ken Hansen. I've been at Microsoft about 22 years, and before that spent 10 years in Silicon Valley at startups. So even I'm kind of used to the small company kind of thing. Now I've got a lot of slides. What I'm really going to talk about is a DevOps at actually Microsoft service. There's a Microsoft service which had a very, and they told me I couldn't tell you the name. I don't know why, but I didn't want to ratchet it up to the VPs because it just didn't matter. In the end, it's a Microsoft SaaS service, which before it was a SaaS service, had hundreds of millions of users, very successful on-prem. And this is some of the gotchas and some of the learnings as we tried to take that and move it to a cloud SaaS service. Make sense? So we'll go through it. This is sort of the size of it. We got 100 plus data centers actually throughout the world, over 1 million servers, so it's reasonably sized by now. The growth is kind of interesting. 2012 here's the beginning. 2015 there, you'll see how it kind of ramps up there to more and more hundreds of millions. We'd observe it's about 1,350% increase over that time period. If you take a look one more year, through the end of 2016, the hockey stick still kind of continues. And in fact, it grows faster, of course, twice as fast as the year before. Were you to normalize this on a flat lane, you'd see a 2x. And it didn't stop last year. I don't have that number for you today, but it didn't actually stop at all. It's been shocking how much it continues. We keep thinking, okay, it's going to slow down any time, and it's not. So we're delighted with that. Now, here's the problem. So when you take a look at data center, this is what marketing shows. And the reality is sometimes just a little different. So today we're going to introduce you to some of our reality. It kind of looks like that, and sometimes it even looks like that, right? Where the guy's just kind of tangled up and lost. And so normally we'd have a tendency to do presentations about this, which is like, look how cool we've got, which is good. But today's a little more on that side of it a little bit. And this is something that I was told once a while back when once in a while I was doing a little bit of dance. It says you have to go through stupid to get to great. And if there's one thing about that whole presentation, that's probably the one key item to take away, is that it's not possible to get great just by thinking about it on a mountain somewhere. You actually got to go and walk the walk and change the code and develop the organization, the process, and the tools that will let you get great. So don't be worried too much about failure on the way, which does remind me a little bit of the talk this morning from Conan, where I was noticing his focus and his mental focus seemed to be a lot on overcoming fear. Does that make sense? Overcoming the fear of change and keeping flowing. All right, so here's the structure of it. We'll go through 5 or 6 or 7 different situations we ran into. Some are duh, and others are a little more complicated, or concepts anyway. We'll tell the action that was taken to address the situation. We'll specify a little bit the results and hopefully craft some learnings out of it that will be useful for you. So the first one is almost what I already said before, which is, look, we had a critical enterprise application, large, successful, many iterations, so it was a complex code base. We had to move it to the cloud. And the first thing we did was similar to what Morningstar did. I don't know if you've seen it. There's a talk by Martin Shu, I believe it is, out of Morningstar. And he's got this great this great talk, little 9-minute thing. But he talks about, hey, look, we recognized we can't actually get it all perfect the first time. So the first step is lift and shift. You're going to have to make changes. So do your best, but don't spend too long without moving. And of course, we were smart enough to focus on just a few 100,000 users instead of the millions, right? And we chose university so we could fail a little bit and no one was going to die and that kind of thing. We did end up meeting pretty aggressive cost targets, went down 10x from when we actually first started in like the first short while, once we got the thing up and running. And here's sort of the two observations, some of which are contradictory. The one says, continual integration is a key to success because it's too hard to know. You can't get there perfectly. I already addressed that. But the second one is that, however, once you get there, it is likely, if you're running a truly historic app, if your app is not built in the cloud, it is likely that you will have to make more architectural changes once you get there because you'll learn as you grow and scale. Does that make some sense to you? You start with what you have, lift, shift, recognize that mostly it's incremental, but not always. All right, but don't forget, don't start, not possible to succeed. All right, now the first problem. Oh dear. The first problem feels like one of those, huh? You actually had that problem? Yes, we did. There's a strong desire as soon as you're starting to move to the cloud, particularly 5, 6, 8, 10 years ago, that you're going to be fast, 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 agile, 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 and everything was going to happen at lightning speed, and life was going to be good. And so we did move really quick. But we didn't, and in the name of speed and velocity, we had no granular access control. So everyone could access all their servers in the database the same in the service if they wanted to. Everybody had essentially full permission. Not complete, but close enough. So this ended after a tester, because this tester had 2 windows up, and he had his test environment, which he'd sort of rip down and rerun tests and rip down and rerun tests and grow the test, because it was a growing service. They were just starting, so it was a pretty active process. And he was doing that work, and then somebody wanted to go look at this production problem. So we opened up another window to go look at the production problem, but then his test units went back to the test window, sort of ripped down the test suite and started up again, a rim-riff kind of thing, except he typed it in the wrong window. And so, of course, everything went completely putz face on him, right? So it was just horrible. And so after that, they said, oh, maybe we should do something about that. So we started with some basic RBAC controls, and you have, and these are important in some ways to think at least carefully, and this is the kind of thing you do before you lift and shift, but think through exclusive control. Who has a data center, who has customer access, who has destructive, what are your God modes? You don't need 100 of them, but you need some. We do a lot less fat finger mistakes now, so that's good. And this is kind of my key takeaway. Speed and agility are important, but don't hurt yourself. All right. Next. Similar but different problem, and we're going to spend some time on deployment, because deployment is key to achieving value for what you want to do. Again, we allowed the devs, we still had to have the right permissions and the God mode and all that stuff, but you could actually push out to the entire service like almost instantaneously, which you use occasionally for hot fixes or other things in a very controlled way. But it turned out that we didn't have enough specific control over it. And so, of course, what happened is that people would push things out, they would fail, and we have too many errors that went too long. In fact, the deployment could go so quick that it was really, really almost impossible for monitoring to catch it until it was kind of too late, right? So I said, okay, we're going to slow down. Now, the obvious way to do that is what everybody does, which is this idea of rings and stage deployments. Everybody's with me, right? And so we do. We have rings. We have stage deployments. We have a ring 0, ring 1, which has the feature team and the division. So we're up to 10,000 people probably then. Then we actually go to Microsoft All, which is about 160,000 by the time we're done. And then we go to a few million customers, about 10 million, that actually have sort of signed up to be our next ring. And then we deploy to the world, right? Pretty basic, simple concept, not that many things. We end up flowing through, just so you have a sense of the volume, we end up flowing through thousands of deployments a week. Someone said it was going even quicker than that, but I know we're at least doing that. So the question is, how do you actually track that? How do you control it? How do you manage it? And that's where the workflow is actually some of the most complex things we got going. So I'm not going to go into the complete detail because your workflow, our workflow might vary, but you have to have rings. Obviously, you need some ability to stop the deploy capability. Frequently, it's best if it's worked off some monitoring. If the monitoring starts to fail, there's some set of alerts. You can actually just stop the thing and let the next one go. Then how do you feed that back in the development chain? How do you feed that back into the Visual Studio where the guy might be working so he knows what happened? It becomes a very key and important loop back. How do you stop the deployment automatically and extract the information that you actually need out of it? We also have done two other things. some of which people might be familiar, well, one of which I'm sure everybody's familiar with, the other one which I've gotten like 50-50 on. We do flighting. We do the feature flags, right? And then we also do this notion of a kill switch. And a kill switch, for this purpose, is atomic and incremental change control. So let's talk about the difference just a little bit so we get them in focus. With flighting, it's off by default because you're doing a dark launch, right? You're sending the bits out there. You want people to actually experiment, and you might turn it on for you and not for you, and I might turn a different one on for you over there, right? And so everybody gets their own service. It's still a configuration, so you can rapidly change it. If one's getting a good success, you can experiment. And it's used for larger chunks of code. They can take dependencies on lower objects of code. When you go to a kill switch, it's a different model. The kill switch says, look, for every bug, and they do this now, for every bug, we're actually going to have a stub of code which decides whether we're going to run your new fix or not. You with me? And the kill switch is on. That is to say, the code is on by default, and it's got to be turned off. So it deploys until something happens. Now, what's great is that you can actually turn it out. So there's no rollback process, no nothing else. If for some reason you end up doing a deployment which is bad, the first thing you do is just stop the kill switch. Seconds, done, right? And then your deployment can still continue because it's no longer a bad deployment. Does that make sense with me? So we sort of keep going, keep flowing. It's a great way to do it. Took advantage of it about 75 times in March, and one of the services did. A key element when you're doing this is you can't take any low-level dependencies. It's got to be high speed. It can't depend on anything else, the code that you're actually using, okay? So kill switch is an interesting concept about atomic control, which you can leverage during deployment to enable deployments to keep flowing through successfully. And you can go back and say, yeah, well, can't you, well, anyway, there's an argument you could make which says, okay, but the next deployment's coming pretty quickly, right? So do you really care? And the answer is, you might. It depends on what's in the rest of that deployment, right? Those bits might really matter, and that little bug fix might not be the important thing in that particular deployment, so just let it keep flowing through. A decision to make. Good news, you can do it. So this is where we ended up. We have very few regressions finally going through, unlike the first 2012 when we had way too many. Now, I don't know what it is. We, of course, got 4 nines uptime, but nobody sees it. I think we have like 1 or 2 a month that actually make it past the Microsoft ring. We catch them almost all by the time we hit Microsoft, before we even hit, and nothing like gets outside SIP by the time we're done. All right. Here's the problem. Rings. Here's what I've observed. You guys might not have seen the same thing. There's a tendency when someone gets burned on a deployment to add another ring, right? Just to slow down the process a bit more because it feels safe. The problem is that rings are taking us the wrong way. They're necessary, but they carry us in a slow direction as opposed to a rapider and more rapid direction. So, right, so there's this conundrum between reliably deploying and deploying. And so it's all about how do you get that speed. Well, if you had 100% monitoring coverage and your thresholds were perfect, you wouldn't need very long in each ring. And go pretty quick. Now, in this particular service, they have spent years fine-tuning the monitoring and the threshold, and the guy talking to me, who actually runs that part of the team, says, I think we're at about 65% or 70% coverage. He says, right, there's no way I can get the full thing covered. We'll keep working on it. We're not stopping, but we have a problem. And so we did a pretty deep think. And the other problem you got with this is that humans make mistakes. And who's creating the thresholds? Somebody, some human, has decided that's the threshold. We had a horrible problem. We ended up with the guy had set it was one of the I/O things, and I believe they set it to like 10,000 or something like that was the right answer, was the answer they said. And it turned out that they'd really only thought about it from from a single pod standpoint. But it turns out that if all the pods arrived at the same kind of 10,000 at the same time, the whole system would sort of go down. And so what happened was we had failure after failure, and then everybody would fail back, because we have a great failback system. We'll talk about that, right? Everybody fail back, but we're starting to lose bandwidth, like, every short while as this problem sort of escalates. You see it spread throughout the number of data centers, not all 100, of course, but a number of data centers. You go, oh crap, what do we do about this? And it turned out that the guy had made a reasonable assumption about the threshold, but it was 2 orders of magnitude off what it really needed to be to solve the worldwide problem. You with me? Humans make mistakes. You can't always trust the threshold. So we've done 2 things. The first one, I think, is just way cool, and the second one's getting cool too. The first thing we said is, let's create a bot. And that bot is going to consume all signals, logs, validations, monitoring, all different kinds of signals. Any signal it can get its hands on, we just plug the dang thing in. It's going to consume all possible signals. And then we do signal processing, Fourier transforms, and others, and we start looking for, is it different than the one before? We don't look for right or wrong. We're not trying to guess that. We're not trying to be that smart. We're just trying to say, is it like 1 standard deviation different or 2 standards deviation different, right? Is it just aberrant in some way? And what's great about this is now, because one of the other problems you got with humans actually determining thresholds is the complexity of determining the thresholds for multiple signals at once, right? Oh, it turns out signal A, signal B, signal C actually indicate a problem, right? How do you determine that? How do you say it? How do you conceive of all the possible, the matrix of possibilities? It's enormous. But the bot can get pretty smart about it. It's the kind of stuff they do. It's like, oh, I'll take these 3 things, I'll take that thing, I'll take the other thing. He can do random sampling. He can change it over time, right? And so the bot does exactly that. That's what it does. It does signal processing. And then, of course, it used a little machine learning. First off, we were over signaling failure, 4x or something like that. And then you sort of dial back, say, okay, well, it turns out that particular case, the signal that you sent, Mr. Bot, is not accurate. It turns out it was a fine deployment. That's an okay thing to let go. It's not a bad aberration. And so the machine learns. With me on this? All right. So that's one thing we actually started doing. The second thing is related but different. And it says, hey, let's start to do analysis on the code in order to do risk-based assessment for this deployment. So now every deployment that goes out has a risk number essentially with it, based upon a static analysis of the code change made, the area it was made in, and the developer that made the change. Which is then brought to their boss. No, it's not. But no, we got the whole thing. And it's compared. The reason you do the risk analysis is you're comparing it via a month plus of historical data or more to sort of back up, okay, what's been happening over time. Does that make sense? So you end up with this heat map of problem areas. Okay, those are problem areas. We have a deployment with that. We should be a little more finicky. And so it actually talks to the bot. It tunes the bot, or at least it modifies the bot's output, so that if it's a high-risk deployment, then it's more sensitive. If it's a low-risk deployment, it goes, yeah, let it go. Yeah, let it go. Right? We're starting to get a great AI and machine learning here, but it's kind of fun to watch how this all sort of comes together. It's worth investing in. I will point out, just since I mentioned the developers, when you actually go through the data, what you find is that the top 10 developers creating the most failures are very consistent. And what we discovered was they were in the yuckiest parts of the code. That's not too surprising, right? On the other hand, it's interesting that the next 10 rotate through. And so, I don't know, those 10 we're going to look at. But anyway, it's just a fascinating, then you could do higher decision measurements, you know what I mean? What's the odds of, anyway. Don't go there. All right. But it's an important piece of data to know, and so we analyze it. So we catch 62% of regressions now. The rest are still caught by standard monitoring, just with the bot itself. And it's normally caught in phase 1 and 2. So it's just caught in the first couple of rings. Catches it pretty darn fast. It is still oversampling, meaning it's not oversampling, it's over-signaling rather. It's saying that it fails a little more than it should. I like that choice a lot better than the other one. Okay, that's a little easier to tune back. And so we're continuing to work on that tuning. And as I say, we end up using the risk analyzer to sort of try to also tune it. The combination is good. I know AI is this new cool thing, but I'm also saying it's useful. So definitely use it. Getting your software to your customers actually is the whole point. If you just take a look at why are we doing all this, is to put software in people's hands quickly. That's why we do it reliably. And so never lose sight of that focus and keep trying to spend money in there. And then this AI and ML really do provide tremendous improvement, but they take investment and time. It's non-trivial. So if you're at a place where you have your deployment rings and you're feeling pretty good about your deployment, that's the next thing for you to start biting off and say, okay, how can I make an incremental change by more intelligently deploying, by intelligently determining risk? All right, here's the other problem. The other problem is that everything fails all the time, right? Once you get to a certain scale, stuff just craps out. And this slide is not complete enough. It just says, look, we got an operation engine that scales with monitoring, deployment, security. It signals the data, and it turns out everything, even the fix itself, eventually breaks. So you have to keep looking back at it. But it also means that you need a mitigation. So failover. Now, we have a tendency to think about failing over to versions, but we've kind of taken pretty good care of that with some of the kill switches and the next deployment coming up and the rings and so forth. But too frequently, people aren't considering the data side of it. What if the data's changed? How do you handle actual data during a failover case? And so we actually have put some fair bit of work into having a very strong data position. On an incident call a while back, a couple years ago, in Chicago was going down, and so the whole data center wasn't working. And so it was kind of headed south, and so the question is, okay, what do we do? What do we do? All right, well, within minutes, we just said, okay, yes, it's really happening, because there's the first check of, okay, are we seeing what we think we're saying? Yes, we're seeing what we think we're saying. Where's the emergency switch? Pull the darn emergency switch, which has failed over to somebody else within minutes. Make sense? Now, as we started, of course, to incrementally improve it, and we use complete failover capability all the time. We do pairing. Sometimes we have four geo-distributed locations of the data. This particular service is very robust, not saying everybody's needs to, but if you have an earthquake in one place, we've certainly seen enough natural disasters in the past few years to make this be a non-zero case. And we continue to improve detection and automation so we fail over for many reasons. Somebody said once, I don't quite buy into 100%, but it's worth just sort of saying, somebody did tell me once, failover trumps every other resiliency effort you make because it handles it for you if it's quick enough and fast enough. So we practice this multiple times a month, actually, failing over to different data. People don't even notice it. It's like the chaos monkey thing. We just keep going all the time, which leads to extremely high confidence. Recently, Tokyo, DC actually went down, and we didn't know it till a week later because it just failed over automatically. The system took care of itself. It was like, oh, okay, everybody's happy. Woohoo! Now it came back up itself. It did a lot of self-repair, but there's it's kind of an issue that sort of goes, oh, okay, that was a non-event, whereas before it used to be, all hands on deck. Okay, so the key is, the learning for me is, look, practice all kinds of failover all the time. And this is, I think, also worth pointing out. It just says, continually failing over, so you're exercising that system, builds confidence in that system. Does that make sense? Now you sleep better. That's good. but it also can give you confidence to innovate quicker because your risk is now lower. Does that make sense? Risk is based upon likelihood of problem and the catastrophic nature if the problem actually occurs, right? It's kind of bringing those two together that actually determine what the full risk assessment is. And so what we've done here is we've started to remove the catastrophic consequences from any failure, which enables us to be more willing to fail faster. And of course, that's also what we've tried to do by catching stuff early in the rings with the AI stuff. All right. And we're going to make it. Monitoring. So it's a hard problem, but it's really important. In fact, my analogy is that this came to me last week, so you all have to deal with it. It just said, my analogy says, this is kind of like the central and the nervous system, kind of like the nervous system, right? You have to know what's happening out here at your fingertips in order to know if you're on fire or not, right? If you remove all your nerves, you remove some pain, but you remove any signaling at all. And so trying to run any sort of service without a strong, robust monitoring signaling system is like trying to walk down a street without a nervous system. It's not going to happen. You're not going to get there. It doesn't work. And then it'll all go, and then carry the analogy too far, the nerves all go back to the brain, which is like the AI thing. You with me there? Okay, good enough. I'm done. I just thought I'd mention it since you're all there. All right. So it's a hard problem. Here's what we've been doing because we've continued to do monitoring, we've continued to do early detection. Actually, what we're seeing over time, the little green line, is kind of the interesting thing. Ignore the hook at the bin. That's 3 weeks worth instead of 4 weeks of data. Anyway, the green line continues, which is the thousands of servers, the counts of number of servers. Notice it continues to climb like the other one. And then what's interesting, though, is the escalations per 100 servers, this yellow line, and it's continuing to decrease. That makes sense? So it's about a factor of 2.5. Some of these are automated, some of them are human. But I just want to get, that's the kind of plot you want to just keep tracking. That's the kind of material we track to say, are we, as an engineering team, making incremental improvements? Are we becoming more efficient? All right? Not going to talk a lot about this. It's just we do a whole bunch of stuff. Outside-in monitoring. This is interesting. At scale, right? We actually test the transactions. So outside in, test, validate, 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 validate is kind of the message we took out of it. Yeah, this is interesting, the two system. Do I have one on that one? No, I don't. Well, then we also do usage-based signaling. We do all kinds of signaling. I'm just adding this one, 50,000, yeah, blah, blah, blah. 1 billion user records per day. We're going to ignore that one for a moment. Here's another part that's kind of makes interesting is, those aren't the only two signals we have. We have lots of them. But what we actually end up spending a little bit of time on and intelligent on is triangulating, if you will, the signals. Combining signals and the scope of where it happens with historical data has a tendency to help you immediately locate the problem place. So this goes back to, okay, we've detected a problem. How do we diagnose the problem? Where is it likely at? And that's where sort of this idea of this is over time actually, and this is kind of the row, and this is and the individual, yeah, rows can be different components, and so the question is, okay, which component is failing when? And so we just sort of keep a continual track of it. And then of course we build back into a basic data insights engine. This is the intelligent part. This is where your monitoring finally pays off. Is just spending the time to think through it. I'm not going to spend any time on that because we're going to start running out. So monitoring, here's my summation. Monitoring is how you deal with life with 1 billion parts. And when you're big enough, this is a quote that, I don't know who said this. I know I've heard it like 1 billion times, so I'm just repeating somebody else's brilliance. It says, look, when you get big enough, unlikely events happen regularly. And impossible events happen occasionally, right? So plan for them, detect them up front, recognize that that's the way you're going to actually trigger it. Nerve system, so even put the nerve system in the slide so everybody knew about it. And definitely, I can't overemphasize this point. I know I've said it probably about 20 times, but you got to work across the full signaling stack. Anything that can send you a signal, you should be looking at, right? If you're just trying one approach, it's probably, I'm guessing, not optimal for you. All right. Now, this is an old phrase I actually like, and this is actually the intent in many ways of monitoring. There's a great phrase which said, and this had to do more as management, because a CEO has a tendency to get into their little bubble sometimes, and they've got all these people who report to them and respond to them. And so one of their biggest challenges is finding out what life is really like for their customers, because they're too recognizable, right? So you got that whole undercover boss thing. I don't know if anybody has that here in the UK or not, but you got that whole attempt, because they're just trying to actually understand reality. Well, what monitoring allows you to start to do is to engineer encounters with reality. And that's also partly why we keep first-level managers still on call, right? And why our organization has a tendency to not use so many SREs. There's pros and cons, but it's because we actually want people to viscerally experience the pain of what they cause, right? It just says that's the learning loop. So don't ever let go of reality. It's the key. All right. The other thing we're taking, well, I've talked about incremental improvements a lot. We're not going to talk about maniacal focus. Look, when you go to worldwide, you have over 1 million servers, 100 plus data centers. It just was taking us too many minutes to get out there. And so we set a pretty aggressive target. We got a dedicated team on deployment performance only. Now, it doesn't matter if you have one person on it, 2 people, 3 people on it, but that's your life's blood. It's worth really, really focusing. So we actually, in this case, they got a team of 4, 5, or 6, I think, actually looking at it. And a different team is on the COGS and reducing every ounce of cost. And so I said we hit 10x before. We're now down to 30x, right? That's all just due to incremental, maniacal focus on the COGS. And here's what's important. So we're way down 6x. We're down to 250% improvement in alerts, 30x cost improvements. But how do we do it? Because you have dedicated teams with intense focus. And this is actually worth noting. In the end, you got to celebrate the victories, right? 1% on $1 billion makes a big difference, right? I could take that home every day. I'd be happy, right? So it's okay. Don't do it. And then we also have a tendency to feed back, similarly on this optimization loop. That's how do we optimize, back to the engineering. So never forget that the dev is actually making the change. You want to make sure he's informed about the change, and he's got all the tools up front. This has a tendency to encourage people to shift left a lot, right? But the farther left you can shift until you're in the guy's actual coding pane, the better off you are. All right, that's about as left as you can get. And then we have a bunch of test systems that are running stuff. And then we actually have a check. There's actually a test for, remember that COGS reduction? It turns out how much memory you use really matters. We actually keep maniacal control of that. And so if a dev checks in a piece of code, we actually run a test for memory to see if that piece of code just messed up our memory stack, or is it shrunk it, or is it grown? If it grows, it's like, hey, we got our you in a moment that says the force is not with you on this. Okay, so that's kind of the next one. Celebrate each victory is the key takeaway, though, because otherwise people will get discouraged and not going to be quite so crazy about their focus, and you never know which one's going to pop. All right. Similarly but different, and I don't have a situation action result thing here. As you start to take a look at the DevOps structures and your team structures, it's going to vary. Some people use SREs, some don't. Born in the cloud has a tendency to use more SREs than non-born in the cloud. At some level, it doesn't matter. There are these 5 types of DevOps teams that work, and that's a great link. If you guys ever want to go, he actually analyzes different teams, explains what one works for what kind of organization, works for the other kind of organizations, and sometimes there's a flow between these. In this particular case, we're pretty much over there on the fully embedded side. In this particular service, that's been working for us really well. So we keep doing with that. But the key takeaway is Build a structure that works for you. Realize that at your company, it's going to perhaps be different. We come here, we learn from each other, we get new ideas, we grow, we improve, but there's not a one-size-fits-all that I've found yet. So don't be bashful about that. All right. Oh, good. This one is kind of fun. Last one you might never run into, but I swear there's a takeaway for you. We had this really hot, a very hot summer a couple years ago, and then the year after it turned out it got hotter, and this year I think it was even hotter still. And so to save themselves, the CPUs in the data centers started to clock down. You with me? Which means essentially that the service's performance was slowly halving its speed over time. And you could see this because we had all the right monitoring, we were checking it, and you're watching this occur in real time going, oh, that's not good. And so we call up, what are we going to do about that? And so we don't want to run the AC too much because of cogs, I don't know. And so we call down to the guys in the data center, what can we do? And we brainstorm for it a little bit. And then the engineers go, hey, what are the fans running at? Half speed? Let's push them to full speed. And so we pushed it to full speed. And it was kind of interesting. We survived the summer, maximum speed fans, but we had an interesting side effect. You might not be able to see it, but the wall actually got pushed out of the data center. Yes. There are unintended consequences for actions you take. That's part of the lesson you get to take away. You're never quite sure what the hell's going to happen when you make a change. Be prepared for anything. We weren't ready for that one. It was like we thought all these other cases, but not, oh, we're going to blow out the wall? Sorry, so I couldn't resist sharing it. So, yeah, ouch. Learning as physics still works. It's okay. It hasn't changed any. There's actually one more piece. There's a part 2 to this, which is nice. Okay, so we already covered the first thing. Now we have a problem because we know we're running too hot and we don't want to get in the situation again next year. We survived the summer. What do we do to diagnose this problem? Right? How are we going to pretend that it's a hot summer? Right? Here, you turn the sun on hotter this week, okay? So we can test that. And then we'll have Steve here turn it lower so we can get back to the rest of it. We don't affect too much climate change or something. So there's this whole problem we got. How do we actually test this? That's how we tested it. We took 3x5 cars, just pasted them right over the fans. Right? Very practical. It works. Sure enough, they overheated. And as one is not surprised, we actually diagnosed the underlying heating problems. We don't have any more heat problems. Didn't have them last summer. Haven't had them ever since. And this is really we're saying, just keep thinking outside the box, man. And direct and simple solutions sometimes kind of work best. There's always a way. My grandpappy actually used to do another random story. I've got a few more minutes. My granddad worked on DC-10 huge bulldozers out in the middle of the Arizona desert, right? He had a couple of them. What that meant was he was building dams and all this stuff and houses and roads, in fact, roads to nowhere, not to nowhere, but to one person's house. And so he's doing all this stuff, but it also means that when they broke down, he was really far away from anywhere. So his favorite phrase, I swear I heard it once a day that I worked with him, was, there are tools at hand, you know? If you got the wrong size socket, you stick sand in it, you put a few twigs in it if it's still off, and then eventually you can get enough pressure to actually turn the darn bolt, you know, whatever it is. He always had all these clever ways of doing things, and I'm simply saying that that mental model of there's always a way, there's the tools at hand, I think actually really helps us here to keep from getting discouraged and say, okay, we can solve this problem. Doesn't matter what it is. That was the point of the fan story. All right. So my summation comes down to pretty simple. One, there is a massive cultural shift. So start and learn. Discover reality. What's it really like? Don't be slow. As a part of that cultural shift, something we don't talk about as much. We do talk about a failure culture, but we don't always talk about celebrating each minute victory. And that's actually probably just as important. Is say, hey, look, you made a small change. it's awesome. We don't care if it's 0.1%. It's better than what it was before. The incremental change is what let us get to 30x, which is huge, which is the same amount, as I recall, the Morningstar got to by a similar approach. Lift, shift to the cloud. Then over time, they containerized. They did all the stuff to make it actually optimal over time as they learn. Celebrate each victory so you don't get discouraged. I have become a proponent, not everybody necessarily agrees, of teams that are dedicated. In order to achieve those incremental improvements, it's useful to have somebody whose job it is to do it. It's useful to have actually an ownership and a sign, not just a generic. So sometimes you have to have teams. Tools matter, as you know, and think outside your box. This is my my observation. As I was doing this slide, I said, look, DevOps in the end has many definitions, but one thing I think we haven't articulated quite as well is the set of culture, processes, and tools to achieve full value of the cloud. If there was another way to do it, we would. If we get full cloud potential doing, we would do, okay? I actually repeated that. I'm kind of impressed. But we don't. We do DevOps instead because DevOps is everything required to do it. So there's nothing that isn't included at some level in DevOps that allows you to get full deployment, take full advantage of the cloud. Make some sense to you? That's kind of it. Thank you very much. We appreciate it. It's been fun. Oh, and I got 4 minutes for questions, but I don't know. You could all go get drunk.
Over the back.
Might be better to have a beer. Just saying.
Coming back to the Killswitch.
Yes, sir.
You mentioned that change has got to be atomic and discrete. How do you achieve that given the volume of change you have running through a system?
I missed the last part of the question. How do I achieve that
given the volume of change you have running through the system, how do you achieve atomic discrete changes to support Killswitch?
It somewhat depends on the service. There's 2 different services that I've actually conflated a little bit. Well, not in that particular case only. The rest is all one. And the answer is we are beginning to enforce that as the developer makes the change, he injects this kill switch. And it's just a number that eventually gets essentially assigned that's then known. It's like this code change now relates to this signal. And then we have a common infrastructure that exists across the entire service that actually has that information. And so when we know that, we actually just flip a bit, and the kill switch service goes up and does a quick check to say, am I going to run or not? It has to be really quick. So we do various distributions and caching to make that high performance. But then you've got to be able to say, okay, should I run this code or not? Yes, okay, move on. So it's just a few clocks to actually do it. So the answer is we insist that the developers start doing it. Now, some teams are encouraging the developer to do it, right? Other teams are going to start insisting the developer do it. But that goes back to the static code analysis and other pre-check-in, pull request approvals we can enforce it with. It's a neat technology. I mean, just to get your head around it, it's an interesting approach to it. Other questions? Oh, one more. All that stands between you and beer is him. I can't. It used to be me. Now it's not. It's him. I'm just. No, ask it, please. We're just teasing you. I had to give you grief. I apologize.
Yeah. So relating to, kind of building off that question, really. So
yes.
A kill switch on a feature and building that atomically. Does that apply to just a brand new feature, or can you kind of
bug fixes?
Or can you roll back if it's an existing feature and then you've modified it? Can you
well,
roll
I want
back
to differentiate.
To a previous step?
Yeah, it's a fair point. I want to differentiate a little between features and kill switch stuff. The feature flag is really the way you want to handle features. They're larger grain, bigger block, and you don't want to put a kill switch around a feature because it's too much code frequently goes into it, okay? That's more of a feature flag kind of a concept. But if you're doing a bug fix or an incremental small change, that's where you want the equivalent of the kill switch, right? And so that's actually where you have the ability to start to granularly say, okay, just this section of code is now going to run or not. You going to answer the question better?
No, I'm going to ask a follow-on to that.
Oh dear, so now I'm in trouble.
Yeah, no.
I knew I should have mentioned kill switches in here.
No, the kill switch stuff's cool. So with the kill switch, you're leaving both the old behavior
Yep.
and the new and adding the new behavior and having a conditional to toggle there.
So over time,
Over time, is that
I'm
process
guessing you're going there.
also like filing an issue to follow up then for the backlog, like in X number of weeks?
How do you
or
remove all
whatever?
this cruft? Is that
Yeah.
your question?
Yes.
I don't know how they're automating that yet. But I've had exactly the same question. I just need to follow up with it. I apologize for my ignorance. But the answer, all right, the answer we could have said is the obvious one, which is, yeah, totally, right? All you have to, because you already know about it. You know about it, you're checking and checking. All you have to do is keep a flag and say, and you know when this deployment continues all the way through, right? That whole risk analyzer thing, it follows each deployment all the way through. So it knows that Bob, which isn't your name, Ian actually made a change 3 weeks ago to this section of code, and here was the deployment result, right? So he's actually able, so it could be smart enough to actually send back to that particular developer and say, now's the time to remove this kill switch around this piece of code. This one's been validated as proven okay. But I don't actually know if, I don't think they're going full stop there yet, but it's the right path. Time's up.
So, thanks, Ken. I really enjoyed that session. It was brilliant. It's nice to end with plenty of humour as well. So, hang around. Bar's opening soon. Algorithmic DJ. So, yeah. And thank you all for coming.
Don't forget, we just want a bit of fast feedback on the event. Go to
/WinOps 2017.
Just give us a little bit of fast feedback on that. So the bar is open downstairs for 2 hours.